Successful landing of Chandrayaan-3 spacecraft's Vikram lander in the south polar region of the moon on August 23rd, 2023 is being celebrated as the National Space Day all over the country. On this occasion, AAR is interviewing Shri S Kiran Kumar sir, who was the former chairman of ISRO. Good morning to you, sir.
Good morning.
Sir, on this occasion, would you kindly tell us how prominent is Chandrayaan-3's success?
Thank you for this opportunity. See, if you want to look at the impact of Chandrayaan-3 and its activity on 23rd of August last year, what it demonstrated is the ability of a country to take an object, reach it to a specific point on the surface of the moon, and then carry out some observation on the surface through its vehicle. That is the basic technological feat which was achieved. And the importance of this or the complexity of this can also be viewed in the context that many attempts happened in the immediate vicinity prior to and post. And also you have seen how all of them had their own issues, while what is India did and ISRO did on this occasion was a very successful attempt, and it shows that it was indeed a complex and difficult task, but effectively and successfully done. So that itself brings out the significance of this activity. But really, if you were to look at from technological considerations, the task was to carry something from Earth, go to reach moon, and then descend on a specific predetermined location, and then make sure that you do a successful touchdown, bring out the moving vehicle from there, and carry out the activities during the 14 days of sunlit period, which was accessible because we were not carrying any powering system which could operate on their own, or non-solar powered powering systems were not there. So as a result of that, this particular task demonstrated what was planned was successfully achieved. See, India started its space activities primarily for enabling the use of space technology for a developing country like India when it started in the late 60s, meeting the demands of communication, of then broadcasting, and also weather monitoring, and for which the capability was built. And even as this capability was being enhanced, we found that we needed navigation activities, so we developed that. And while all this capability is built, you also need to understand that technologically, if you want to improve, you need to keep challenging both the engineers and scientists who work in that area. And taking up more and more challenging tasks is the way to improve your capability for solving even problems for what you are doing using the space technology. Because going beyond Earth enables you to do long distance communication, and then designing systems which can survive extremes of environment and also in conditions very different from what you find near Earth. And if that has to happen, you need to do challenging tasks. So beyond traveling from Earth at 36,000 kilometers, where we had built many geostationary satellites providing us weather monitoring, broadcasting, communication, etc. Moon was the nearest object beyond that at around 380,000 kilometers. So we were looking at how can we build a system which can reach there and move on. And in fact, though we did our program on Chandrayaan-1 in 2008, man had landed on the moon and a large number of probes had touched the surface. But still, it made an impact because it gets the credit for discovering the presence of water molecule and the process of water molecule formation with Chandrayaan-1, where it was an example of working in collaboration with many international bodies, international entities. The next step is, after orbiting the moon, the touching down on the surface is another important technological capability. So Chandrayaan-2, we were attempting to do that. But then one of the requirements of that was to build an engine which is throttleable. And throttleable engine was being developed for the first time for Chandrayaan-2. And then any new development also has its own challenges and complexities. And the other aspect of Chandrayaan-2 was that we were touching down on a specific location near the south pole of moon. And depending on the information available up to that point of time, we had chosen a location where we had a margin of error of only 500 meters. So from the orbiting moon to touching down on that would have required certain information set which was limited at that point in time. So then by Chandrayaan-3, whatever lacunae that were there in Chandrayaan-2 in terms of smaller area being identified, then capacity for carrying fuel was limited, and many of the activities happening for the first time, then the whole process actually, finally we were very close to touchdown, but we fell short by a small amount. But then using Chandrayaan-2 as the ladder for the success, identifying all the problems that occurred in Chandrayaan-2 were all built into the Chandrayaan-3 program, and we were able to successfully do. Now, if you look at this, what is it trying to tell? It is trying to give you a capability of going to your nearest planetary body and then make observations on that and provide information which will be useful for a whole lot of new things. Like I said, after Chandrayaan-1, the human interest on going to moon increased tremendously because of identifying that water is a possibility there, and that water can act as a source for future fuel requirements and even for surviving on moon, etc. So this particular Chandrayaan mission, if you look at in that sense, has been in many ways very significant because it rekindled the interest of the humanity to go. Otherwise, after the 70s, it was a low-key activity going on. Correct. So that was one of the key things what Chandrayaan did. It was basically an effort on our part to throw more and more challenging tasks to our space technology community so that we can do more competent activity from space for enabling humans sustain themselves on Earth.
Sir, when you mentioned about the Chandrayaan-1 conclusively discovering water on the moon, I remembered at that time it was hailed as a path-breaking discovery, in fact. And you said that if I'm correct, Chandrayaan program has a logical progression from Chandrayaan-1 orbiting and hard landing and an attempt to soft land and now fructification of that. That brings me to the next question. You thoroughly reviewed Chandrayaan-3 mission before it was launched. When you look at the performance of the various mission elements, including the spacecraft, the launch vehicle, and the ground station network, everything, how do you characterize it, sir? Are you satisfied?
See, one of the things is obviously you have a specific task on hand and you have a set of resources in your hand. So the real challenge in any mission is to match the resources you have with the task you want to do and successfully deliver it. That is the primary thing. So once the mission is conceived, at the time of conceiving Chandrayaan-3 mission, all the learnings from Chandrayaan-2 had been incorporated in terms of the hardware. But then when you are actually doing the mission, what is on your hand? You already have the launch vehicle at the launch pad, it's going up. Then the propulsion module and the lander rover. They have all features which are designed, built into that. And you have a certain set of resources provided in that. So your task is to really make sure that all the systems that are supposed to be working in that, they are verified for operation before they are brought into actual use. So if you have an engine, and if an engine has been developed new, and if that has to be characterized as part of its in-orbit operation, then it ensures you success, because if some modifications are required in your programming, you can incorporate them based on the tests you conduct. While for all those engines which are performing with fixed thrust mode, we have enough experience. We have experience from all our geostationary satellites and even launch vehicles. In all of them, we have fixed thrust engine operation. So here there was a variable thrust engine operation, and then 4 of them operating together, any imbalance in that. So one of the key things was how to build in features in the mission planning, which will ensure that you can validate the performance while it is in orbit before it is actually brought into operation. So this is a key aspect which was built into that. And similarly, for example, when you had to land, you have to land in a specific location. See, what is the real task of landing when you are orbiting? You are moving around the moon at a speed of about 1.6 kilometers per second in a 100 kilometer orbit or 100 kilometer by 30 kilometer orbit. So at a given point of time, you are moving with a velocity of 1.6 kilometer per second. Then you want to bring it down to zero on the surface. So you encounter two types of issues. One is you have to reduce your horizontal velocity to zero. If you make your horizontal velocity zero, then the moon's gravity start pulling the object down. And if you don't do anything, it will keep accelerating. So if you don't want it to happen, you have to keep providing a compensatory force on your thing. So this is where the throttleable engine comes. And you need to measure it carefully. And then from the starting point to the end point, all your trajectory, you should be able to measure various parameters, your velocity, your direction, and build in your algorithm a suitable methods of thing. So all this, based on Chandrayaan-2 experience, we had made sure that they are all verifiable even after launching while they are operating, so that you build that confidence into the mission operation. And like I said, in touchdown, this time we had identified a 4 kilometer by 2 kilometer area, where within that any 100 meter area you are having a point for touchdown, so that it gives you large margin for error. So in this manner, the experience of Chandrayaan-2 helped successfully navigating Chandrayaan-3, because all the issues that cropped up during that time, and also the ability to carry more fuel and build more robust algorithms for operation, they all become essential components of this process. So the whole process of reviewing and seeing was primarily to make sure that, like I said, you are carrying out a mission with certain specific resources in hand to visualize what are the operations required during the course, which will make minimum use of the resources you have, doesn't excessively spend, so that you do not have enough leeway for dealing with subsequent activities. So many of these were the essential components of those reviews and activities. And notwithstanding all that, finally the safe touchdown and then the rover coming out and moving around is a demonstration of what has been done. See, otherwise there are umpteen number of things which can still show up at the wrong point in time and cause difficulties. But then, to the credit of all the people who have been putting their sweat and blood for this activity, so it was a successful attempt, and we were able to make sure that we landed in an area where nobody else had gone, and also collect information about that region, which it becomes a sort of a virgin data for any new scientific studies.
So it was very significant, and practice made one perfect, and there was meticulous planning. Now, the landing of Chandrayaan-3 on the moon, innovatively in an area where nobody had done earlier, no doubt about it, it was a technological accomplishment which was very significant. But would you kindly tell us what are the scientific contributions of Chandrayaan-3 to the domain of science?
See, if you look at any science, when you have to look at it, it first looks for certain set of observation. So in Chandrayaan-3, we had a number of instruments which were carried both in the lander and rover, and these instruments made specific observations. For example, there was a Ramba called a Langmuir probe, which measured ions, electrons, density at a height of about 2 meters from the surface of the moon. And this data was collected continuously for about 12 days of its operation. Then we also had what is called a LIBS, laser-induced breakdown spectroscopy, where a laser is fired and then based on the evaporation that takes place, making measurement of molecules and atoms, and then study the characteristics of that material. Then you also had on the rover the LIBS instrument as well as APIX, what is called APXS, that is a alpha particle X-ray spectroscopy system, which measured at 23 different locations in a circle of 550 meter radius. So then it made observations by firing the alpha particle and then taking data, which showed in a way what were the actual materials that are present there, and it showed that this entire region is very homogeneous, and also it has got certain elements at a concentration which is very different from what other observations have been done in previous missions closer to equator, etc. And then by once making an observation that there is uniformity and there is something different from what's seen elsewhere, actually ask for why has it happened, how can it happen. So this is where the scientists come up with models and try to bring in explanation that probably this is what could have happened and this is what explains the higher occurrence of certain types, that apex was there. And then similarly, this also carried a seismometer on the lander, which could not only measure, it could detect the movement of the lander and the rover around it. Then in addition to that, the total data that is collected is under the process of analysis by various people. There was also an instrument called CHASTE, which measured conductivity up at a depth of 80 centimeters from the surface of the moon. So many of them are first time observation. So one is to make sense out of the observation and bring in some explanation for why it is showing the kind of results that it is showing. So in this case, we were able to do for the first time in a region where nobody had done so far. So the efforts are on both in terms of bringing scientific results out of that, and also these results will be made available to the international research community also, so that the modeling and then various activities related to that can proceed. So basically science can only be improved with new observations. So new observation is what provided with Chandrayaan-3, and then what kind of instruments were designed for that. Of course, they are in a many ways resultant of your capability of what you can do. You have certain resources, within those resources what you can do. So that's how it's progressing.
So technology enables science.
Yeah.
Again, and I'm sure that a lot of papers will be coming out.
Yeah, already there are some Nature papers, etc. Nature has already given one of the things with respect to APXS. So similarly, there will be a lot of them which will be coming out. And this data also will be available to all the researchers both in India and outside.
That's noble, sir, really. And one small question, why moon is so important for humans today?
Okay, see, if you really look at the basic question that anybody asks is like, why do you do something? It is like somebody was asking a question, why do you want to climb Mount Everest?
Yes.
The person said, I want to climb Mount Everest because it is there. So like that, moon, once you see moon has been an object of the human, actually you can say activity in all spheres of life. And that is the closest celestial object to us. So obviously the curiosity of what is moon, what is there, what can be done is one of the things. But beyond that, when you are looking at, today we are looking at moon. For example, India has already announced by 2040, we will not only carry humans to moon and land there and bring them back. So if you want to do such a thing, what is the interest? So moon is being looked at as an observatory. That means you can make observations with moon as the point. So setting up laboratories and setting up observatories there for looking at Earth or looking at space. It can also provide you certain very distinct advantages with respect to electromagnetic radiation, shielding. One side of the moon can act as a shield for signals coming from Earth and then make very faint signal observation. So moon is being looked at as an observatory. Moon as an observatory. Then moon as a place for exploitation of resources there. See, naturally, the newer and newer resources you find, there will be some applications for that. So looking at what is available on moon and how can it be used. Then moon as a manufacturing place. That means it provides a unique opportunity, condition very different from Earth. So it doesn't have the atmosphere. In those conditions, certain different kinds of manufacturing could be possible. So using that as a manufacturing place. Then moon as a stepping stone for travel beyond. That means many times what we see, even in the past also you have seen, when man started moving on animals and moving, so he was identifying some places for stopover. That means refueling, providing food for himself. So same way moon can become a stopover point where you can refuel, or you can build systems there and you don't have to carry all in one go from Earth. So moon as a stepping stone for traveling beyond. Because traveling beyond solar system and into other parts of the universe is going to be a continuous or the pursuit of human beings. So he will come up with propulsion technologies. Today you may have only 10 kilometers per second, but he is already looking at how to increase it and how to reach speeds of light, etc. So there is a huge opportunity for these things. And then beyond that also, if you look at moon also as a place where humanity wants to use and bring in collaboration, coordination, regulation, because going beyond Earth and monitoring from space is a unique capability which will help protect Earth from many situations. But in this, if you have to collaborate and cooperate with others, who are the people who are going to do that? It is only those who have the capability to do this. So the nations are looking at, not only nations, even private entities are also looking at how they can build systems which can go. So moon is a very important element in the human endeavor for exploring the universe beyond Earth itself or beyond our solar system. And like in an eternal sense, the ability to make newer and newer observations with more and more capable observing systems, and observing system being provided appropriate locations for observation is all part of the human development endeavor. So in that context, moon being the closest celestial object is naturally a point of interest, and it will continue to provide a very challenging and also an opportunity for humanity to look beyond.
So you would say that urge to explore is in the human psyche. So that is natural, and moon is the first step because it is the nearest heavenly body to us. On the occasion of the first anniversary of the successful landing of Vikram lander of Chandrayaan-3 in the South Polar region of the moon, we are celebrating it as the National Space Day, as was directed by the Honorable Prime Minister Modi ji. On this occasion, special occasion, what's your message to our large student community in India, sir?
First thing is, we definitely need to celebrate our successes, and then celebrate successes which are actually have made a mark even in international segment. So in that context, landing Vikram lander and Pragyan rover and identifying that point as a Shiv Shakti point itself, that event itself should become an inspiring activity for the people. So because of that, this has been identified as a space day. Now if you look at space itself, it is the natural instinct of humans to look beyond and see what is there in space. Why is it so vast? What are the things? So the urge to explore space is again another intrinsic human nature. Now already the government has announced that we will build our space station by 2035. Our own human space program is already on, and then in a year or year and a half, you will see humans going around Earth. And government has also announced that we will land on moon and bring back Indians from moon. So that means 2040 is 16 years from now. Now, who are the key people who are going to be participating in those activities? And there is a huge challenge. Huge challenge is life being taken out of Earth, moving to different parts, and then deciding on what kind of environment you should provide to them so that they are sustained and they are protected and they are comfortably brought back safely. All requires huge amount of research and then exploring new ways of doing things. A lot of creative things are required. India is only just entering into this arena. So unless more and more people participate in this activity and more creative and aspiring minds work on that, these things are not going to be easy because resources are always going to be a constraint. So within the limited constraints, how to achieve larger aspects or bigger things demands the human creative capability to be constantly exercised. So in this context, these days, the events like this will actually bring to the awareness of the students and also showcase to them that these are the nature of the challenges that exist and what is the solution they can bring in. And another aspect of these kinds of solutions is also what already the space programs have shown, that the solutions what you have found for a specific problem has multiple uses and spin-offs. So you will be able to make use of your new discoveries, new capabilities, which will take you beyond identifying the, for example, life forms, science, data science, artificial intelligence, building miniature, micro or macro robots, and the whole lot of things in all these areas. It is possible for the next generation to look at how they can do things very differently from what others have done. And also, like I said, what Chandrayaan-1 showed is it is never too late in science and technology area. That means there is always something new for humans to find.
Yes.
And what is the real inspiration for the humans to see this? It is actually nature. And nature is showing us so many things. It is only those who are able to make observations of what is happening in nature and then try to bring it into reality with the tools that we have today are the ones who are moving ahead. Whether it is in medical field or in
Space.
propulsion, space, you name anything, even artificial intelligence.
Yeah.
In every one of them, it is human beings are seeing what is happening around them, are trying to bring into reality. So in this context, events like this remind the students of the tremendous opportunity and the challenges that the government has set up for the next generation, and in their participation, how they can look at, how they can think beyond today, because space is the fourth frontier for humanity.
Yes.
In the long run also, human beings are looking at if and when Earth doesn't become sustainably livable, by that time should you not have found out an alternative place for survival, like that.
So you feel that awareness about achievements like this will definitely inspire the student community.
Awareness about the achievement and the awareness about the possible challenges that can be tackled with their capability. So if you point it to them, then they can actually take advantage of that and they can show. In fact, the Indian intellectual capability has already demonstrated to the world what it can achieve in terms of flooring both the external world and internal world is a huge thing.
Yeah.
So it's only bringing awareness which helps. And this particular type of National Space Day is a tremendous opportunity. All minds to explore the entire thing. External or internal is only incidental.
So reminiscing about this achievement benefits the individual as well as the country and the world at large. So thank you, sir. Till now we heard an interview with Shri S Kiran Kumar, sir, who was the former chairman of ISRO. And this broadcast came from All India Radio, Bengaluru.